So what we're going to look at first is this idea of linearizing data. So first off, what is linearizing data? So linearizing data is just a method of transforming the graph of our data into a linear graph. So we saw back here, we have a linear graph that we can look at, that we can use to help us think about data. Here's just a nice little example. A lot of the time we get these polynomial, we get these x squared, these quadratic type graphs, and we use these graphs, but wouldn't it be cool if we could look at this graph immediately and say, oh, I can understand some data from this. From a quick calculation, I can figure something out about this graph. So we want to be able to look at the slope of a graph and instantly recognize what the growth factor between our variables is. So a graph that we have like here in this case, this quadratic or this polynomial type graph, it's a good graph, it's nice, but we know the relationship for this is like y equals ax squared, but it's really difficult for us to get an a value from that to tell us, hey, how is y growing with x squared? That's really difficult. If we had a linear graph, we could just find the slope and say, oh, well, slope is our change in our rise over our change in our run, and that's super easy to calculate. Something like this, to calculate the growth factor between a y and an x squared relationship, that is really difficult. That's something that is really hard for us to do. So what we have to do when we do this is first we're going to have to identify the relationship between our variables. So we have to say, how are these variables, how are they related to each other? Then we're going to have to set up some sort of substitution. We're going to perform that substitution. Then we're going to graph the substituted variables. So this sounds really tricky, but really what it is just a substitution, which you guys have done in math class. So I'm going to show you an example. Really quick, these are just our different factors. I'll just kind of reference these. But so we have something that is not really related. We just have y as a constant. Usually we won't really get with that. If we have a linear relationship, that's fine. We don't have to do anything because we know that our graph is already linear. If we have this inverse graph, we know that y is inversely proportional to x. So y is related to 1 over x. So then we'll have to do a little substitution with this one. If we have this polynomial, if we have this x squared graph, we say, oh, y is related to the square of x. Then we'll have to do a little bit of substitution with that. And then if we have this y squared versus x, we usually won't see these, but it's on our list of things that we have to watch out for. So I'm going to jump in and we'll do a practice one, and that will be in the next video. So I'll kind of show you a data set. I'll show you why we may want to linearize it, and then we will go from there. Okay.